It is August 27th, 2026. This research overview is AI-generated, covers a partial daily collection, and requires human review before its claims are reused. 33 supplied paper analyses are represented in the source pack, but retrieval failures and missing table content weaken parts of the record. Today's clearest theme is a change in what counts as success. Researchers are moving from outputs that look plausible towards systems that actually complete verifiable contracts, maintain state, and survive long sequences of actions.
The strongest evidence comes from two agent benchmarks. Frontier Challenge tested 97 scientific workflows requiring consistent bundles of code, figures, tables, and reports. The best two configurations each completed only 20 tasks, or 20.6%, even though their average rubric scores reached the high 80s. SWE Refactor Bench found a similar gap in repository migration. Only 28 of 520 runs passed the audit, every fixed check, and 6 independent verifiers. 60 submissions that passed all fixed checks were subsequently broken by a verifier.
So, partial credit can conceal a fatal missing deliverable or a contradiction between artifacts. That is measured evidence within these benchmarks, not proof that all scientific or coding agents fail at the same rate. The editorial connection is nevertheless useful. Both studies treat completion as a contract over mutually dependent outputs. Frontier Challenge used single runs on a released non-GPU subset, while migration acceptance depended materially on the verifier panel. A concrete next test is to add deliverable ledgers, cross-artifact consistency checks, and differential self-testing, then measures strict completion rather than progress alone.
Visual reasoning shows the same tension between progress and complete success. VGI Bench asks video generators to perform short visual procedures while respecting intermediate rules. Its leading model scored 51 on the composite measure, but achieved only 14% strict success. The evaluator agreed with pairwise human preferences 73.2% of the time, so it is informative but imperfect. By contrast, VBVR Pro builds procedural tasks with deterministic, task-specific scorers. On a matched 50,000 example setting, reinforcement learning from those scorers reached 0.548 overall, ahead of model judge rewards at 0.508.
The author's supported conclusion is narrow. Deterministic verification produced better results in that matched VBVR Pro experiment, and intermediate visual states appeared important. It does not show that hand-built scorers can cover arbitrary imagery or that visual reasoning generally beats language reasoning. Those scorers require manual engineering, while VGI Bench covers only 5 to 10-second English image-conditioned videos. Across several papers, decomposed criteria recur as checklists for video instructions, visual faithfulness, reward modeling, and interface repair. Treating that recurrence as a shared design pattern is editorial synthesis, not evidence that one project influenced another.
Multi-teacher language model distillation also became a resource allocation problem. One study scheduled domains using both the remaining teacher-student divergence and recent learning velocity. It reported a best 7 benchmark average of 62.34 at step 95, compared with 61.36 at step 143 for a fixed mixture. OpenMOPD diagnosed why fixed allocation can fail. Instruction following represented 20.3% of prompts, but received only 0.99% of tokens because its answers were much shorter. Its full method raised recovery of the routed teacher headroom from 35.6 to 83.4%.
Those results support adaptive budgeting inside the reported 4-domain and 3-domain pipelines. They do not yet establish a universal scheduler. One experiment lacked multi-seed uncertainty. The other assumed oracle routing, one 3 billion parameter model, and 3 domains. A decisive follow-up would compare divergence and velocity scheduling, reward gap scheduling, and validation-based allocation under the same pipeline. Researchers should vary teacher count, response length imbalance, and routing error, while tracking both capability gains and forgetting. That would reveal whether these methods address a general optimization problem or mainly compensate for the particular mixtures tested.
Persistent state forms another cluster. VoiceMem separates factual memory from persona and affective memory, then retrieves while a person is speaking. On its 316-question audio benchmark, it scored 68.73 versus 53.95 for the strongest listed baseline, with dense retrieval reported at 134 milliseconds. But most outcomes were judged by language models, benchmark construction details were deferred, and the latency number excludes the full speech-to-response pipeline. The measured result is retrieval performance under the paper's setup. Claims of seamless conversations still need real user and device testing.
Generated worlds pursue persistence differently. Code World model keeps rules and hidden state in executable code, then compiles selected state into a rough video guide. Its evidence is qualitative, so control and latency advantages remain author claims rather than quantified findings. Joy AI Echo uses learned audiovisual memory and camera control, reporting an 81.7 navigation average, but difficult 60-second paths accumulated 12.05 degrees of rotation error. Stream 4D instead rewards geometric and motion consistency, producing sizable reconstruction score gains over 3 backbones, though its longest evaluated horizon was only 10.3 seconds.
The editorial comparison is explicit state versus learned memory versus reward-based stabilization. It suggests a useful experiment, not a proven hierarchy. Make a world change while off-screen, return minutes later, and separately score object identity, geometry, camera pose, and hidden state. Current demonstrations mostly span seconds or 1 minute. Long-duration tests should also report error as a curve, because a good endpoint average can hide accumulating drift. For conversational systems, an analogous question is whether bounded retrieval preserves contradictory, sarcastic, or ambiguous evidence without turning temporary emotion into a permanent user trait.
Reliability problems also appear in graphical interfaces. Under synthetic runtime anomalies, all 16 tested Android agents degraded. A separate minimal pair study found the best strict spatial grounding accuracy was only 0.313. Depending on the spatial primitive, 60.3 to 92.5% of predictions selected neither candidate element. These studies diagnose different layers: live recovery and static localization. They do not demonstrate that one causes the other. The next step is a layered benchmark that isolates candidate detection, relation selection, action verification, and loop recovery, then tests unseen and compound anomalies.
Efficiency results were promising but conditional. Prefix sliding kept instructions plus a bounded recent reasoning window. At 128,000 generated tokens, a 4,096 token window delivered 5,224 tokens per second versus 448 for full attention, while nearly matching the reported math score. Coding needed at least a 16,384 token window. Gated recurrent transformers reduced parameters and decoding memory in sub-billion parameter experiments. Together, they motivate selectively preserving important intermediate states, but the connection is editorial and requires matched tests across math, coding, and tool use.
Several valuable single studies broaden the day. A 104.2-hour brain imaging speech corpus showed that extensive data from one deeply measured participant improved top 10 retrieval for participants with little data. A modular CT system reached 94.1% accuracy on pairwise axial slice relations, far above direct visual question answering, though it did not test full volumes. A high-resolution weather model reported a 4% overall error reduction against its stated operational baseline, but only over one future evaluation year, with synthetic data and comparability concerns. These are notable measurements, not directly rankable achievements.
The main limitation across the collection is uncertainty. Most papers provide point estimates without repeated seeds, intervals, or significance tests. Several depend on language or vision model judges without complete human validation. Some source retrievals failed, one analysis was substantially truncated, and another omitted major numerical tables. Metrics span incompatible tasks, hardware, horizons, and model sizes, so cross-paper ranking would be unjustified. Historical links in the source only identify technically comparable questions. They do not establish chronology, citation, influence, or priority. Human reviewers should inspect the underlying papers before treating any headline as settled.
The concise takeaway is that this partial day rewards systems that verify completion, allocate learning effort where it remains useful, and preserve only the state needed for reliable long-horizon behavior. The measurements are encouraging, but strict success rates, evaluator dependence, short horizons, and limited replication leave substantial room for research. The most actionable questions are whether pre-submission verification raises complete task pass rates, whether adaptive schedulers survive routing errors, and whether persistent memory remains correct over minutes rather than seconds. For paper-by-paper details and links, continue to the linked daily summary.